So paleomagnetism, which is also known as the fossil magnetism, some of the rocks of them, rocks and metals of that like iron, cobalt, nickel, they can magnetized, and this magnetization is related to the electron spin. When electrons, all the electron spin are aligned in particular direction, that substance is said to be magnetized. When the substance is heated and later cooled, especially when heated to Curie point temperature, and its magnetic field is applied in between, the substance gets aligned into in the direction of the dense and magnetic field. Therefore, it will preserve two things about the its magnetic properties: at what location, what time, what was the properties of its magnetism, which are magnetic declination and magnetic dip. So such rocks preserving its magnetic field are called fossil magnets, and study of such rocks and magnetic properties in geological past is called as the paleomagnetism. Next, we have paleomagnetism as evidence of crustal movement. This is the most confirmatory and most reliable evidence for continental drift. So in studying the fossil magnets or the magnetic rocks, it reveals some magnetic anomalies. For example, this rock here, it was showing that according to the declination, it was showing the direction as this thing, and the dip showing dip when calculated, it shows the dip of 20 degrees south. So the dip angle did not match the latitude of the place or the Earth's magnetic field, which is shown from dip and the declination. So this can be explained by PTT and continental drift theory, that rocks can get magnetized at some location and sometime later continent will drift, and at the new location also the magnetic properties of the preserved at what place and what time. Therefore, for example, during the Carboniferous period, during the Pangea at 20 degrees south, this might have get magnetized with the declination showing this time, and now it may be over 70 degrees north where the declination is right now is here, but it shows this direction and the dip of 20 degrees south. So this is the explanation offered by PTT and CDT. Next, we have the polar wandering curves. So Blackett is a person who did the paleomagnetic studies and gave this. So so by tracking the magnetic rocks and layers of lava plateau, it revealed that north and south poles of the magnetic north and south poles seem to migrate. So this is the lava plateau, this is the oldest and this is the youngest, and we have these layers. So the declination and dip are like this for each thing, and the dip is 30 degrees, 40 degrees, 50 degrees. So according, if we plot all this on the map, we'll get that north pole is as if north pole is wandering. But and in reality, the magnetic north pole is more or less stationary, and the lava plateau is actually drifting through the hotspot and the different layers are formed. So we can say that because of drifting of the lava plateau, the apparent movement of pole is happening rather than actual pole wandering. So Wegener also tracked the similar polar wandering, but he did not do it on basis of paleomagnetism. Rather, he used the glacial deposit studies and glacial drift. So according to him, he gave the South Poles in Silurian period at northeast of Madagascar, Carboniferous at near Durban, and during the Tertiary period at 53 degrees south, just south of South Africa. So we can see Silurian, Carboniferous, Tertiary, and now we have it in Antarctic. So the paleomagnetic evidence is a continental drift theory here, magnetic anomalies we have already seen, polar wandering we have seen, study of bands of opposing polarity on either side of Mob we will see now. So ocean floor mapping was done in 50s and 60s, as we have studied already. So it revealed that age of ocean floor, it increases away from the more presence of a more trenches, axial rifted more, transform fault, all this. So also at Atlantic more, reverse polarity burns like mirror image on either side of the more was found. At other more locations also the same thing was confirmed, especially the Carlsberg Ridge in Arabian Sea. Extensive study of these bands was done. So Harry Hess, who gave us reflow spreading, could not explain why this mirror image reverse polarity bands are found, but Van and Matthews of Princeton University, they were able to offer an explanation on basis of Harry Hess's reflow spreading and self-reversal of Earth's magnetic field. This was the fact that was known to them. So they combined these two and gave it an explanation for this. So according to them, the magnetic polarity reversals of the Earth have happened at 4 million years. It was Gilbert reversal. 3.2 million years Gauss normal, 2.5 million years Matuyama reversal, and now we have the Bruns normal. So we can see here on the mirror image side, we have Bruns here, Matuyama, Gauss and Gilbert. The polarity is reversing in each one. So this is the normal and this is the reversal, normal and reversal, and you have the mirror image on this side of the more. So what are the reasons for the reversal given by them? Reasons for the reversal of the its polarity is not convincingly known, but the reversal is the reality. So Wine and Matthews, they explained that more basaltic eruptions they happen, so the basalt happens, and at that period they get magnetized and they preserve the magnetic properties. So they cool and solidify and preserve the magnetic properties. Later, Earth's magnetic properties reverses, and then again the reverse thing is stored, and the new lava is solidified, and the same process repeats. That is why these alternate bands of like mirror image happen. So we can say that seafloor is like a magnetic tape recorder preserving the history of magnetic reversals of Earth.